Okay, good afternoon, pilot teachers, and good afternoon, students.
Good afternoon.
Thank you. Sit down. Okay, our lesson today will conclude our work on calculation of gradients, and the conclusion will see us complete the correction to 2 of the activities you were assigned to do for your homework, and then we will move on to looking at construction of cross sections in our lesson today. We'll start off first with the correction to the homework that was assigned, and the homework was to look at, from the worksheet that was distributed, calculating the gradient for example E on the worksheet and example F. Let's look at the answers and also your calculation for finding the gradient for those 2 examples. Okay, we'll start off with the contour pattern E and the steps for the calculation of gradients together with the answer for that particular activity. Okay, for exercise E, you check. The lowest point is 45. Note that it will have to be 45 because the dot is not right in the middle between 40 and 60 for it to be 50. So our answer for the lowest point is 45. The highest point is very close to 180 contour line, therefore we'll take that as 179. We get the difference. And when we get the difference, it will be 134, which is the vertical difference. We find the distance between point A and point B. We measure from this point to that point. And our measurement should see us come up with 5.4 centimeters. Therefore, to get our 5.4 centimeters to meters, we use the scale. The scale of that map is 1:50,000. Therefore, 5.4 centimeters multiplied by 50,000 and divide by 100. And the reason for why we need to divide by 100 is so that we can convert our answer into meters. So we come up with 2,700 meters as the horizontal distance. Okay, to calculate our gradient now, we found the vertical difference, 134 over 2,700 meters, that is. We simplify 67 over 1,350. We cannot further simplify, therefore we divide the numerator into itself to give us 1 and the numerator into the denominator to give us 20.15. So that answer will be a gradient. That particular contour map would have a gradient of 1/20 or 1:20, which means for every 1 meter we rise, we go 20 meters across, or for every 20 meters we go across, there is a rise of 1 meter. Okay, you do your corrections. Okay, let's move on to the second activity you're supposed to complete for your homework, and this time exercise F. Look at exercise F. Calculate the gradient between the 2 points again, point A and point B. We'll check the lowest point first of all for exercise F. The lowest point, you need to make corrections to this one also. The lowest point is 98 meters. Okay, 98 meters. See how we got 98. The line goes from A to B, and along that line you will see it goes between the 100 and the 80 meters. So the lowest point is actually not 110. The lowest point is 98 meters. You check. If you did draw that line, you would have found out that the lowest point is this, 98 meters. The highest point is between 160 and 140, but not right in the middle. It's closer to 160, so therefore we'll get it as 155 meters. The distance from A to B is 4.7 centimeters. Therefore, the vertical difference is taken by simply finding the highest point and the lowest point. We're subtracting the lowest from the highest. 57 meters is our vertical difference for exercise F. Horizontal distance is 4.7 centimeters multiplied by 20,000 because the scale is 1:20,000. Divided by 100 so that we can convert our answer into meters, and we get 940 meters. The gradient, therefore, is 57, the vertical difference, over 940, the horizontal distance. We cannot further simplify this. Therefore, we divide the numerator into itself to give us 1. Divide the numerator into the denominator to get 16.49. We can now round off. The gradient for that particular map is 1 over 16, or 1:16, which means for every 16 meters we go across, there is a rise of 1 meter. Okay, corrections are done for the homework. Now, any questions with regards to what we have done on gradients? Any questions? No questions? Okay, then we will move on to looking at how we can also classify gradients using the information on our chart here. And you can also refer to the monitor, of which that contains the same information. Okay, if we look at classifying of gradients, sometimes some people might be thinking that what does 1 in 1 mean, or 1 in 2 mean? We can also use words to describe a gradient having completed the calculations. And when we are looking at the classification of gradients, these are some of the common terms which are used to describing a gradient of 1 in 1, or 1 in 2, or 1 over 1, 1 over 2, etc. So we'll start off first with a gradient of 1 in 1, or 1:1, or 1 over 1. When you have calculated a gradient and you ended up, or you will end up with 1 in 1, it simply means the the slope of that particular area is a very steep slope. You have a very steep slope if you calculate the gradient and you find that the gradient is, for every 1 meter you go across, there is a rise of 1 meter. A gradient, after calculating, has 1 in 2, means that the slope is going to be a steep slope. After having done the calculation, and if you come up with a gradient of 1 in 3, or 1 over 3, or 1:3, it means that, again, the slope is going to be a steep slope. A gradient of 1 in 5 means the slope is steep to moderate. A gradient of 1 in 10 means that the slope is a moderate slope. A gradient of 1 in 20 means that the slope is gradual. And finally, a gradient of 1 in 40 means that the slope is a gentle slope. Maybe to see what type of activities can take place or occur on those slopes, we can look at some examples here. A slope which has a gradient of 1 in 1 means that it is very steep. That means it's dangerous for you to actually climb. You might need to use the equipment to get to the top if you are going to or trying to climb that particular area. A gradient of 1 in 2 will be difficult to climb. You may climb, but it might be difficult. Again, you will need proper equipment to perhaps get to the top of that feature. A gradient 1 in 3, usually roads are filled in, or there are cuts made on the roads to allow for the road to actually be or to pass through. A gradient of 1 in 5, it will still be considered as a steep road. A gradient of 1 in 10, which is moderate, the vehicles traveling to the top will need to go on low gear. That means gear 1 or gear 2. If you go on 3 or 4, the vehicle will lose power. You'll have to change it back to 1 and 2. So a slope 1 in 10 is still it's moderate, but again, vehicles going to the top need to go on low gear. 1 in 20, limit for easy cycling. So for those people who use bicycles, that could be the limit. It's easy to cycle maybe to the top and then down again. And 1 in 40, very gentle slope, but then for the railway to be actually constructed, it will still be considered very steep for construction of railways. So generally, we can also look at gradients and we can classify them using the following terms to tell us perhaps that particular area is very steep if it has 1 in 1 gradient, or perhaps 1 in 20 if the slope is gentle. So if people use the term gentle, gradual, steep to moderate, then you can have a fair idea on what the gradient is actually like if you did the calculation. Questions? Any questions with regards to this? Okay, if there are no questions, that will also conclude our work on calculation of gradients. You need to be able to practice so that when it does come to our testing and assessment, and if you are asked to calculate gradients, you should be able to calculate correctly, knowing exactly what to do, know the vertical difference, know the horizontal distance, make sure the unit that you are using are in meters, and at the end, always give your gradient as a ratio or a fraction of 1 is to something or 1 over whatever you have to calculate. Okay, in geography, gradient must always be given as a ratio or as a fraction of 1 is to whatever or something. Okay, if there are no questions, we are now going to move on to looking at what we are supposed to do for the lesson today, and that is construction of cross-sections. If we look at a cross-section and we come back to looking at contour patterns, one of our lessons back, we looked at contour patterns, and from the patterns, you were able to identify different types of landforms. And the different types of landforms, if you did recognize the patterns, you were able to work out. If the contour patterns were nice and secular, and the heights increase as you get to the center of that particular contour pattern, then straight away you would say that that is a contour pattern of a hill or a mountain. If you had a contour pattern of which there are two circular areas on both sides, there is a depression in the middle, then you can tell that that could be a contour pattern showing us a twin peak with saddle. Sometimes it is difficult to look at contours or contour patterns and work out what type of feature it will show. Using a cross-section might be able to help identify that particular feature in reality, or what we can say, looking at the side view of that pattern, of that feature from a pattern. So today we are going to look at construction of cross-sections, and we will try to also see how we can identify landform features in reality by constructing cross-sections. Looking at the information from our monitor now, a cross-section is a side view, and a cross-section shows the relief along a line as if the land has been sliced open by a giant knife and then viewed from the side. This idea can be compared with a loaf of bread. The loaf of bread is cut with a knife to produce a slice of bread, and the slice is a cross-section of the loaf. Cross-sections are useful for showing the following. 1, the changing slope and shape of the land, and that is what we will work on for our construction today. 2, cross-sections are useful also for showing how landforms influence vegetation, land use, and settlement. If the area is a bit too steep, we find that we don't expect a lot of people to build their houses there. How do we know whether the area is steep or not? By looking at the contour patterns. Perhaps if we construct a cross-section, we can be able to tell whether that area is very steep or not so steep. And also, cross-sections are useful for showing the visibility between two places. So those are the 3 usefulness of why we need to construct, or why there might be a need to construct cross-sections. Okay, now we are going to do some activities together, and the activity that we are going to do together will be construction of a cross-section, and I'm going to actually go through the steps, and I will teach or demonstrate how to actually do the different steps in the construction of a cross-section, and you also will be required to follow those steps. So we are going to construct a cross-section of that model together. What you need for your construction then, you need a piece of paper. Any piece of paper, if you can find a piece of paper, you get one. You need your exercise book, because our cross-section will be constructed in our exercise book, and you will need a pencil for you to use for your construction. So see if you have those 3 equipment ready now for our construction. Okay, if we look at the information from your worksheet or also from the monitor here, it says that the aim is to draw a cross-section of the relief along the line AB. You will be given topographic maps and you might be required to construct cross-section along different areas. For the construction now, we will use this example of the contour pattern. If you look at the pattern itself, straight away you can say it is a pattern of Twin Peaks with a saddle. Let's find out what this feature would look like from the side or the side view of it. We are going to construct a cross-section from point A to point B. Step number 1, you take your piece of paper and I'd like you to place the edge of that piece of paper along the line AB so it would look like what is shown here. So your piece of paper, you place it along the line AB. Okay, once you've placed that piece of paper along the line AB, I'd like you to mark the points A, where the A comes exactly on that piece of paper, and I'd like you to also mark the line B, or not the line, but the point B, on your piece of paper. Step number 2. Also, on the same piece of paper, I'd like you to mark each of the contour lines that crosses that line AB on your piece of paper. And I'd like you to mark those lines accurately on your piece of paper. So you place your piece of paper along the line AB. You have already marked point A. You've already marked point B. And now you mark every contour line which you can see that crosses along the points A to B. Okay, once you have got the contours marked, then the next thing you are going to do is you are going to put in the value of each of those contour lines that you have marked on your piece of paper. You start off with A, find out the value of A. You do the same for the second line or the second point that you've marked on your piece of paper, find out the value, and you do the same right across to point B. So you write in the value of the contour that meets with your piece of paper. Okay, now you have numbers on that piece of paper and you also have the points or the strokes or the dots to indicate those contour lines plus the values of each of those contour lines. Let's go on to step number 3. We are not going to use another sheet of paper, but rather we would use our exercise book. So in your exercise book, you are going to prepare a blank frame. Mark the left side as A and the right side as B. In other words, we are going to construct a frame of which we are going to put our cross section on. So our frame must have a vertical axis and it must have a horizontal axis. We are all going to use the scale in our exercise book. For every 0.5 centimeters, for every 0.5 centimeters, you are going to go up by 20 meters. So you measure the vertical axis. For every 0.5 centimeter, you go up 20 meters. while you're working on that, we check the highest point that you have labeled on your piece of paper would be 220 meters. Is that right? The highest point on your piece of paper. Is it 220 or is it 200 meters? 200 meters. Okay, so the highest point on your piece of paper is 200. Therefore, the vertical scale must cater for at least an extra 20 meters up so that we don't come to the end of the feature right at the top of our graph. This is to cater for that 200. So we just go up an extra 0.5 and label or indicate that that is 220. That is for the vertical axis. Okay, what we have got on the vertical axis are the heights in meters. So you label that particular axis also as heights in meters. That's on the vertical axis, this axis here. Okay, for the horizontal axis this time, I'd like you to pick up your piece of paper for the horizontal axis, and you put the piece of paper right at where the 0 is on the where you've constructed the horizontal axis. Put the piece of paper so that the letter A is right along where the vertical axis is, and the length of the horizontal axis must be exactly the length of point A to point B that you have on the piece of paper. So the length of the horizontal axis must be the exact length that you have for point A to point B. You indicate, as soon as you've done that, you indicate point A and you also indicate point B. Okay, we're still on step number 3. We are now preparing a framework for our cross-section to be actually placed on. Are we ready to move on to step 4? Yes? Okay, good. Our frame, if you have done your construction according to the instructions given, should look like what is shown on the monitor. You have the vertical axis from 0 with intervals of 20 all the way to 220. 200 is the highest point, so we've gone just 1 point higher or 1 more interval up. And the horizontal axis that's from A to B should be the exact length of what we have on our piece of paper. Okay, not information, but step number 4 now. We are going to transfer the information we have on our piece of paper now onto our framework. When we are transferring the information, it is important that we keep the letter A along the vertical axis. And we are simply going to move the paper to whatever height for the first stroke, and you put a dot to indicate. Then you check the second height. You move your paper still along the vertical axis to that height, and then you put the next dot, and the next, until you come to point B. Okay, you are going to use the dots to show for every contour line that passes from point A to point B, making sure that the distance is exactly what is shown on your piece of paper. You slide the piece of paper along the vertical axis, keeping A always where the vertical axis is. And you check the heights of each of those contour lines on your piece of paper. And you plot accurately where they come in using a dot. So the first type, yep, A right on, waist 100 done. Okay, all the way up. That's it. Put a dot there. Okay. Second one, 120. That's it. Put a dot there. Okay. 120. Big dot, so you can see. Okay. The next one, 140. That's it. So that's how it's done. Got all of them done? Yes, good. Don't forget, you rule that line, but that line there is going to be the exact distance from A to B, and label A, B. Okay, there is actually no need for you to rewrite all of those because it's already on your piece of paper. And by putting the dot, we will already know. So you use the piece of paper just to go. It's a piece of paper that you did.
This is meant to be the one on this.
You've done for the, okay. So we are working on the other one. That's okay. We can double check to see the steps followed should be what you should do for that one also. Okay, okay. Let me. Why is it right down here?
No, I made a mistake. That's why.
Okay.
This is for the homework you gave last
Okay, okay. So you're going to redo?
Yeah.
Okay. Oh, so this is, that's okay. Okay, when you come to the top, don't try to make it flatter, just leave it as a, it looks correct, yes. Okay, most students have already done the plotting, so we'll check if you had plotted correctly. See the next height from A to 100, 120, 140, and you are climbing as we're going along to 180. Then there's another 180 again. Then you come back down to 160. And if you did the plotting correctly, you should have the dots as shown on the monitor here in this shape, from here up, down, and then up again, down to where letter B is. Okay, then for the next step now, we need to get our pencil, and using freehand, do not use a ruler. Using freehand, you connect the dots. And when you do the connecting or you join the dots, you should have a smooth curve to show the cross-section of the relief along point A to point B. This is what your cross-section should actually look like. A smooth curve from point A to point B. Another important maybe skill that you should also be made aware of. Sometimes cross sections will be constructed for you, but you will be required to identify along that cross section where the features come in. And if you are told to do so and a cross section has been done for you and all you have to do is actually identify where the feature comes in, we do the same thing. You get your piece of paper, you put it along the line AB, and then you mark in accurately where the feature is. You go to the cross section, and then on the cross section, you mark in where that particular feature should fall in. Like, say, for example, the case of the road. There is a road there on that cross section, and if you had to mark along your cross section that you've constructed where the road will come in, you cannot guess. You'll have to be accurate by using that same piece of paper, putting from point A to point B, finding where the road meets your piece of paper, and then you put the piece of paper onto your cross section to identify where on the cross section the road will come in. Okay, some of you are trying that out. Good, you can go ahead to trying that out. Similarly, if there are other features that crosses or that passes or that you will see along the cross section, like maybe there might be a river or a road or a track and etc. And if you are asked to plot accurately where the river comes in on your cross section, you do the same thing. You put your piece of paper along the two lines, point A to point B, and then identify where the feature comes in, and then put that feature onto the cross section you've constructed to show where it falls in on your cross section. Okay, we look at the last but not the final. You check any good graph that we construct must have the labels on the graph. So check, have you got the horizontal axis labeled? And if it is to be labeled, then the horizontal axis is supposed to show the distance from point A to point B. So you label distance from A to B on the horizontal axis. On the vertical axis, we are showing the height in meters. And this particular cross section also will need a title. So our title then here is the cross section of point A to point B. And that would be the title of that particular graph. Okay, and if we've done all of the steps correctly, then our cross section at the end would look like what is shown here. Okay, I'm going to give you your homework now, and your homework is going to be some more practice of the construction of cross section. So if you can refer to the handout, which contains the different contour lines. There are 6 of those contour lines. They're lettered A to, is it H? Yes, A to H. And I will ask you now to do at least 4 more construction of cross sections into your exercise book. And the 4 activities that you will use for the construction of the cross section will be B, you circle, contour map C, contour map E, and the contour map G. Those are the 4 that I would like you to practice, and I'd like you to do the construction in your exercise book. I will also check on the other cross section, which is on for X to Y later on. Anyone has any questions you'd like to ask with regards to what we have covered so far on construction of a cross-section? No questions? Okay, that will also bring us to the end of our lesson today. If you can stand up now, please, class. Okay, to the pilot teachers, our keyword for today is relief. That's for lesson 15. Good afternoon and thank you, students.